In this lecture, let's talk about the Coulomb's Law. Coulomb's Law is named after the physicist Charles Coulomb. He found the mathematical relationship that described the force interacting between two charges. So we know that there's electrostatic force between 2-point charges. When they have opposite sign, they attract. When they have the same sign, they repel. In a quick note, here we'll be talking about point charges. Point charge has no physical size. The magnitude of the force between 2-point charge is a constant times the product of magnitude of the charge of the 2-point charges divided by the distance between the 2-point charges squared. The constant is the Coulomb's constant. It is 8.99 times 10 to the power of 9, and the unit is newtons times meter squared divided by Coulomb squared, because we want to make the entire thing to have unit of newtons. These two, Q1 and Q2, they both have unit of coulombs, and R squared is the standard unit for distance, which is meter squared. So the constant in front must cancel out the units of Q1, Q2, and R squared. Then we multiply an extra newtons to make the entire thing has unit of newtons. We can also write the Coulomb constant as 1 over 4 pi times epsilon naught. Epsilon naught is the permittivity constant, which is 8.85 times 10 to the power of negative 12, and unit is 1 over the unit of Coulomb's constant. These two both describe the magnitude of force between 2-point charges. This constant, Coulomb's constant, equals to this, 1 over 4 pi epsilon naught. We've already talked about direction of forces between charges. When they have the same sign, then the force will be in opposite direction because they repel each other. Similarly with this case, when we have two negative charges, so again the force is pointing outward. And when we have two opposite signs, when we have a negative charge with a positive charge, they will attract each other. So the force will be pointing toward the other charge. And a quick note, the electric force is conservative, similarly to the gravity force. So there's a potential energy between the 2-point charges, and it is only their position or the distance between them that matters the potential energy, not the pathway. For example, if I have two charges here, they have some potential energy between them. If I move one of them around like this and go back to the initial point, the potential energy is the same. Here's a quick quiz. Charged spheres A and B exert repulsive forces on each other. We know that the charge of A is 4 times the charge of B. Which statement is true? A. The force A on B is greater than the force B on A. B. Force of A on B equals to force of B on A. C. Force of A on B is smaller than force of B on A. You can pause the video here before I move on to the solution. So the answer is B. Force of A on B equals to force of B on A, even though they have different charges. And that is because of Newton's third law. The force interacted between two objects. They have the same magnitude, but in opposite direction. That is the third statement here. Newton's third law applies. Force of 2 on 1 is the negative of force of 1 on 2. They have the same magnitude, but they point in opposite directions. Here's another quiz. An electron and a proton, initially separated by a distance r, are released from rest simultaneously. The two particles are free to move. When they collide, they are A. At the midpoint of their initial separation, B. Closer to the initial position of proton, C. Closer to the initial position of the electron. You can pause the video right here before I move on to the answer. So the answer is B. When they collide, they are closer to the initial position of the proton. Because from Newton's third law, they have same magnitude of force. But from Newton's second law, net force equals to ma. mass times acceleration. And mass of proton is greater than mass of electron. So when they have the same force but different mass, then the acceleration will compensate so that they have the same force. So the one that has smaller mass will have a greater acceleration, which is the electron. So proton that has greater mass, it will have a smaller acceleration. It will move slower. So when they collide, it will be closer to the initial position of the proton. And that is the end of the lecture. In this lecture, we cover Coulomb's law. We talk about the magnitude of force and the direction. In the next lecture, we are going to look at an example on Coulomb's law.